Hello everyone, in this video I have discussed one numerical based on direct map technique. So how does this direct map technique work? I have explained in one of the other video. So you can check the link of that video in the description below. So let's see the numerical. So the question says we are given some of the data and we have to find some of the answers. So the question says we are given the main memory address which are equal to 32 bits, okay, and the size of the main memory is 512 MB. Okay, now the size of the cache is 256 KB and we have used the direct mapped cache. Okay, now the next thing we are given is the block or the line size of the main memory or the cache is 16 words. Okay, and we have to assume that one word is equal to 1 byte. So on the basis of this information we have to find these answers. So let's write all these things into a diagrammatic form. So let's say this is our main memory and this is our cache. Okay, so as we know that main memory is organized in form of blocks. Okay, so the question says that the block size of the main memory is equal to 16 words. That means we have the blocks inside our main memory. So this is block 0, 1, 2 and so on. Okay, so each of the block contains how many words? 16 words. So this will be like word number 0, word number 1 and last will be word number 15. The same way block number 1 will contain word number 16, word number 17 and so on. So last will actually be word number 31 and here from word number 32 your words will be starting. Now this line also says that the size of your cache lines is equal to 16 words. So you know that in cache we will have certain lines. Okay, so this is your line number 0, 1, okay, 2 and so on, and each of the cache line is also of like how many words? 16 words. Okay, so that means the block size or the line size and the block size of the main memory is equal 16 words. Okay, now the next information is that main memory addresses are of 32 bits. That means these addresses of the main memories will be of 32 bits. Okay, so okay, these will be of 32 bits. Now next thing is the size of the main memory is 512 KB. Okay, so our total memory is of 512 MB. Okay, megabyte, and the size of your cache is 256 KB. So total cache is 256 KB. So these are the information that we are given and we have to assume one word equal to 1 byte. So first question is that we have to find number of blocks or the lines in your cache. Okay, so we have to find that how many these total lines are there. So here we are assuming that blocks and lines are the same terminologies. Okay, although there is a subtle difference between the lines. Okay, line contains the tag and the main memory blocks, so in that way line and blocks differ, but for the time being let's assume block and line are the same thing. To find the number of lines in the cache, what we can do, we know the total size of this cache is what? 256 KB, and each of these line is of how much size? 16 words. Okay, so that means each of these lines contain 16 words. Okay, 16 words, 16 words, 16 words and so on. So that means we can compute this way by the aptitude form, that 16 plus 16 plus 16, these total words will make how many things? This total word till x time they can make 256 KB. Okay, so here you can assume 16 words means 16 bytes. So 16 bytes, 16 bytes, 16 bytes till x time. Okay, if you add them, then you will get 256 KB size thing. Okay, so in this way you can say 16 multiply x, it will be of 256 KB. Okay, and in this way x, which is denoting number of cache lines. Okay, so it is 256 KB divided by your 16. Okay, so if you solve this, it will be 2 to the power, this is 8 into k is 2 to the power 10, this is bytes, and again this is also 16 bytes, divided by 16 can be written as 2 to the power 4 bytes. This is cancel out, and if you solve this, then you will get 2 to the power 18 divided by 2 to the power 4, and it will be 2 to the power 14. If you solve this 2 to the power 14, you will get 16384. So these many lines will be in your cache. So you can say your last line will be 16384 3 because line are starting from 0. So total these number of lines will be there in your cache. Okay, so you need not to actually do all these things. You can directly apply the formula. Formula is like simple, your total cache size divided by the size of each cache line. Okay, so total size of the cache is 256 KB and the size of your line is 16. So you can just divide both of the things and you can find the answer. Now let's move to the next question. So the second question says we have to draw the main memory address format which is seen by the cache. So what does it mean? Let's say CPU asks for some main memory address. Okay, so all these memory addresses are of how many bits? These are of 32 bits. So it will generate 32-bit address. Okay, when this address is presented to your cache memory, then you know in direct map technique this address is actually divided into 3 fields. And what are those 3 fields? Those are tag, line number and the offset or the word offset. So your 32 bits are divided into these 3 fields in direct map technique. So this 32 bits in 3 fields will be presented to your cache memory, and cache memory will be seeing this type of address in 3 fields. So we have to tell that how many bits will be there for tag, then how many bits for the line number and how many bits for the offset. Okay, so you know what is this word offset? So this word offset help us to recognize the particular word present inside your cache memory. Okay, so as you know there are total how many words inside your cache line? So there are total 16 words. Okay, so to recognize 16 words, how many bits will be needed? Let's say you have the only 4 words inside your cache line. Okay, for the timing let's assume this. So if you have, let's say, 4 people, okay, and you have to give them unique addresses, then how many bits can be needed? So you can give them 00, 01, 10, 11. You can address them in this way. That means 2 bits are okay to address 4 people. The same way, if you have 16 people or the 16 words, then how many bits you need? So that means when we have the 4 people, then we can express this 4 as 2 to the power 2. So we need this 2 bits. The same way, if we have, let's say, 8 people, okay, then how many bits we will be needing? The 8 people will be given 111 this, and the first people will be given the bits as 000 this address. So you can see that we will be needing 3 bits. So for 8 we can write 2 to the power 3, so 3 bits will be needed. On the same analogy, for 16 words or the 16 bytes, we will be needing 2 to the power 4, that is 4 bits, okay, to recognize 16 words inside your particular cache line. So this offset will be of 4 bits. Now next thing is line number. So what does this line number tells us? This line number help us to recognize the particular line number of the cache memory. Okay, so again it will depend on how many lines are present into your cache memory. So we can see here in our first question that number of lines present into your cache memory are 2 to the power 14, and 2 to the power 14 was 16384. Okay, so this is actually 2 to the power 14 minus 1. Okay, so to address this number of people, that is 16384, okay, which can be expressed as 2 to the power 14, how many bits I will be needing? So again the same thing, we will be needing 14th bit to address this number of people 2 to the power 14. Okay, so that means this line number will be of 14 bit. Okay, so remaining bits will be for the tag. So you can say tag will be your 32 minus the sum of 14 and 4. So your tag size will be of total 14 bit. That means this field is of 14 bit. So if you add 14, 14, 4, you will get how much answer? So you will get total 32 bit. Okay, so this is the memory address. So you can see that in this question we actually do not need this main memory size. Okay, so this was actually like redundant data that was given to us. So I hope this question is clear to you. If you have any question, comment or suggestion related to this question, please write down into the comment box. And if you like the video, please like and share this video among your friends, and do subscribe the channel and press the bell icon for further notification. Now let's move to the next numerical.